extending health span. The earlier we start, the better the outcomes. But even for those already in their 60s, 70s, or 80s, it's not too late to reverse part of the decline and begin restoring strength, mobility, and confidence. 1. The role of diet in rebuilding muscle. Step and one bite at a time. For decades, dietary advice around muscle preservation and strength has centered on one concept. Eat more protein is a recommendation often made without nuance or understanding of how the type, source, and timing of protein can influence not just muscle growth, but also long-term health and aging. The truth is far more complex. In our work studying aging and longevity, particularly at the cellular and molecular level, we found that not all proteins, and certainly not all protein sources, have the same effect on the human body. In fact, some of the most commonly promoted high-protein foods may offer short-term benefits for muscle while simultaneously accelerating aging and increasing the risk of chronic disease. Protein is essential. This is not in question. It provides amino acids, the building blocks of tissues, enzymes, neurotransmitters, and crucial immune components. As we age, the body becomes less efficient at using dietary protein to stimulate muscle protein synthesis, a phenomenon known as anabolic resistance. To overcome this, older adults often require slightly more protein than younger individuals, but more protein is not always better, especially when the source is rich in saturated fat, heparin, or pro-aging amino acid patterns. This is where the quality and origin of protein become essential. Research from our lab and others has consistently shown that diets high in animal-based proteins, particularly from red meat, processed meat, and full-fat dairy, are associated with increased levels of IGF-1 insulin-like growth factor 1, a growth hormone that, while essential during development and wound healing, becomes a liability when chronically elevated in adulthood. High levels of IGF-1 stimulate pathways such as mTOR and AKT, which promote cellular growth and proliferation. In younger individuals, this supports muscle building. But in older adults, sustained overactivation of these pathways has been linked to accelerated aging, increased cancer risk, and shortened lifespan. In contrast, individuals who consume primarily plant-based proteins, such as those found in legumes, nuts, seeds, and certain whole grains, tend to have lower IGF-1 levels, lower inflammation, and better metabolic markers. These plant proteins may not have the same immediate anabolic potential as a steak or whey shake, but over time, they support a healthier rate of aging. What's more, plant-based protein sources often come bundled with fiber, polyphenols, and anti-inflammatory compounds, which contribute to improved gut health, cardiovascular function, and immune resilience. This is a central concept in the longevity diet, which we developed after analyzing the diets of populations with the highest concentrations of not all proteins are equal centenarians from Okinawa to southern Italy to parts of Costa Rica and Lom Minda. Despite vastly different geographies and cultures, these populations share a common nutritional pattern, a moderate protein intake, primarily from plant-based sources with limited consumption of red meat and near zero reliance on processed animal products. They are not necessarily vegan or vegetarian, but they use animal proteins sparingly as a side, not the centerpiece. It's important to note that plant proteins can still support muscle health, especially when paired with resistance exercise and consumed in adequate amounts. Specific amino acids such as leucine, which is essential for initiating muscle protein synthesis, can be obtained from plant foods like soy, lentils, chickpeas, pumpkin seeds, and spirulina. Even better, many of these foods provide additional longevity benefits, including antioxidants and soluble fiber. We've also observed that it's not just the type of protein, but the amount and timing that influence outcomes in early adulthood. High-protein diets might promote athletic performance and in body mass, but in middle age and beyond, high total protein especially from animal sources, can increase mortality risk, particularly from cancer and cardiovascular disease. In our 2014 study published in Cell Metabolism, we found that adults aged 5,065 who consumed high-protein diets had a 75% increase in overall mortality and were 4 times more likely to die of cancer compared to those on low-protein diets. However, this trend reversed in individuals over 65 where moderately increased protein, especially from plant-based sources, was associated with reduced mortality and better muscle retention. This underscores the importance of age-specific nutrition. A diet that may benefit a 30-year-old may be harmful for a 55-year-old and vice versa. The goal always is to find the balance between supporting muscle function and metabolic health while avoiding overstimulation of pro-aging and disease-promoting pathways. Another overlooked consideration is how protein is processed and prepared. Even a healthy source like chicken or fish can become problematic if deep-fried, preserved with nitrates, or cooked at high temperatures, producing advanced glycation end products AS, which contribute to inflammation and tissue damage. Similarly, many high-protein processed foods, protein bars, powders, and snacks are often loaded with artificial sweeteners, poor quality oils, and emulsifiers that disrupt gut health and undermine long-term wellness. So the message is not to avoid protein, but to be deliberate and informed about its sources. Think of protein as a therapeutic tool, powerful, necessary, but capable of harm if misused. Choose sources that support not just muscle growth, but also healthy gene expression, leucine, the amino acid that matters most, cellular regeneration and immune function. Favor legumes over red meat. Choose lentil soup over a steak. Embrace the power of soy, quinoa, and whole plant combinations that deliver complete amino acid profiles without sacrificing longevity. Ultimately, the goal is to preserve strengths without compromising lifespan. By understanding that high-protein foods differ vastly in their impact on aging, we empower ourselves to make choices that support both functional independence and a longer, healthier life. Protein can be part of the solution, but only when chosen wisely and always within the larger context of a nutrient-dense, longevity-focused dietary pattern. In the context of aging, one of the most important biological challenges we face is the body's reduced ability to build and maintain muscle. Even when older adults consume enough calories or protein, the muscle tissue often fails to respond as robustly as it did in youth. This phenomenon is referred to as anabolic resistance, and it represents a central barrier in the prevention and reversal of age-related muscle loss. At the cellular level, anabolic resistance occurs when skeletal muscle becomes less sensitive to the signals that promote protein synthesis. In younger individuals, a small dose of dietary protein or moderate resistance exercise is often enough to trigger muscle repair and growth. But in those over 60, the same stimuli produce a weaker anabolic response, meaning more effort is required to achieve the same results. Over time, if this imbalance is not corrected, muscle mass declines, strength diminishes, and the risk of frailty increases. Fortunately, research has identified a specific amino acid that plays a key role in overcoming anabolic resistance: leucine. Leucine is a branch-chain amino acid, BCA, that serves as a direct trigger for the M2R pathway, a molecular switch that tells muscle cells to begin synthesizing new protein. When leucine levels are sufficient, this signal is activated. This one plant-based food that changes everything more efficiently, even in older muscle. This makes leucine-rich foods particularly important for aging populations seeking to preserve or rebuild muscle mass. Now, while many people associate leucine with animal products such as eggs, whey protein, or meat, there is growing evidence that certain plant based foods can deliver comparable leucine content, often with the added benefits of fiber, antioxidants, and anti-inflammatory compounds that support overall longevity. One standout example is fermented or minimally processed soy foods such as temp, tofu, and edamame. These foods are unique in that they offer a complete amino acid profile, rare among plant proteins, and are particularly high in leucine relative to their total protein content. Temp, for instance, contains approximately 1.5 g of leucine per 100 g, which is comparable to some animal sources. What makes soy-based proteins especially powerful for aging adults is their ability to stimulate muscle protein synthesis without activating the same level of IGF-1 overexpression seen with excessive intake of red meat or dairy proteins. In our work on the longevity diet, which is grounded in the dietary patterns of long-lived populations and supported by laboratory research, we have consistently emphasized low to moderate protein intake from plant-dominant sources with an emphasis on functional foods like legumes and soy. These foods not only help counteract anabolic resistance, but also avoid overstimulating the progrowth pathways associated with accelerated aging and cancer risk. A major advantage of leucine-rich plant foods like soy is that they offer a more balanced anabolic signal rather than flooding the system with gross triggers. They provide a gentle nudge enough to stimulate muscle repair without pushing the system toward pathological overgrowth. This is an important distinction, especially for those in their 50s, 60s, and 70s, when the goal is no longer maximal muscle gain, but rather functional preservation, maintaining enough muscle to support mobility, independence, and metabolic health. Moreover, plant-based leucine sources are often accompanied by other longevity-enhancing compounds. For example, fermented soy products contain isoflavones, which have been shown to support cardiovascular health, reduce inflammation, and even modulate estrogen receptors in a protective way. These benefits are additive. They work in parallel with the muscle supporting effects of leucine to create a multi-system strategy for healthy aging. Some critics argue that plant proteins are inferior because they may require slightly larger quantities to achieve the same anabolic threshold as animal proteins. While this is technically true, it misses a key point. Most older adults are not suffering from excess muscle mass, but from chronic disease, inflammation, and a diet that promotes aging. The longevity perspective is what makes this food so unique, about balancing short-term functional needs with long-term health outcomes. And when viewed through this lens, leucine-rich plant proteins are not only sufficient, they are preferable to overcome anabolic resistance effectively. It's also essential to time leucine intake strategically. Research shows that consuming a leucine-rich meal within 2 hours after resistance exercise, even light activity like resistance bands or body weight squats, significantly enhances muscle protein synthesis in older adults. This combination of targeted nutrition and consistent physical activity offers one of the most powerful tools for reversing age-related muscle decline. Another important consideration is the form and digestibility of the protein. Fermented foods like tempeh and miso are not only high in leucine, but also easier to digest, especially for older adults who may have reduced stomach acid or enzyme production. This enhances amino acid absorption and maximizes the impact of each meal. In conclusion, while no single food is a miracle cure for muscle loss, certain leucine-rich plant-based options stand out for their ability to bridge the gap between muscle preservation and long-term health. These foods allow us to address the very real challenge of anabolic resistance without compromising on our broader goal to live not just longer, but better, stronger, more independent, and more resilient into our 80s, 90s, and beyond. It is this convergence of function, safety, and nutritional density that makes this class of food, particularly soy-based protein, so powerful in the context of healthy aging. by focusing on the quality, not just the quantity of protein. And by leveraging the muscle-stimulating power of leucine, we can help older adults reclaim strength and vitality while still adhering to the principles of longevity, nutrition rooted in both science and tradition. It is a fundamental truth in biology that structure determines function, and nowhere is this more apparent than in the muscles of the human body. Skeletal muscle is not merely a tool for movement. It is a highly responsive, metabolically active organ that contributes to immune function. Glucose, how to combine this food with resistance, exercise regulation, mitochondrial health, and even bone density. As we age, however, the muscle becomes less efficient, less responsive, and more prone to degeneration unless we intervene with both nutrition and movement. Neither works in isolation, but when combined intelligently, especially in the context of aging, they create a synergistic effect. One that far exceeds what either could accomplish alone. This synergy becomes especially powerful when we pair a leucine-rich plant-based protein such as soy with regular resistance training. On its own, a nutrient-dense diet can provide the amino acids, vitamins, and anti-inflammatory compounds necessary to support the maintenance of lean mass. And exercise, especially resistance exercise, stimulates the mechanical and cellular pathways that initiate muscle repair. But when these two strategies are timed and aligned, they activate both sides of the muscle building equation, the signal and the substrate. Let us begin with the physiology resistance training. Whether with weights, resistance bands, or simply body weight, causes small-scale damage to muscle fibers. This is not harmful. In fact, it is necessary. This damage stimulates satellite cells, growth factors, and the M2R pathway to begin rebuilding the muscle stronger than before. But for this process to occur efficiently, the body needs the right building blocks, essential amino acids, particularly leucine, which acts as the metabolic unswitch for muscle protein synthesis. Without this key amino acid, the stimulus from exercise cannot be fully translated into growth. This is why post-exercise nutrition matters even more in older adults who already experience anabolic resistance. In a younger person, almost any high-protein meal after exercise will support some degree of muscle growth. But in someone over 60, the response is blunted. This is where targeted nutrition becomes essential. A food that is rich in leucine and easy to digest, such as tempeh tofu or a soy-based smoothie, can overcome this resistance, providing the precise amino acid signal needed to activate the repair pathways. Studies have shown that consuming a leucine-rich meal within 120 minutes of resistance training significantly improves muscle protein synthesis in older adults, even with modest exercise routines, and the training itself does not need to be extreme. In fact, research and clinical observations suggest that moderate consistent resistance exercise 2 to 4 sessions per week is sufficient to sample daily meal plan for seniors stimulate meaningful gains in muscle strength and function, particularly when paired with proper nutrition. For aging individuals, this might include squats, using a chair, wall push-ups, resistance bend rows, or slow stair climbing. The key is to challenge the muscles in a safe, repeatable way. But why is the combination of food and movement more than just additive? Because muscle is a dynamic tissue that responds to integrated signals. When we provide both a mechanical stimulus via exercise and a nutritional stimulus via targeted protein intake, the response is not simply linear. It is amplified. The exercise increases blood flow to the muscles, improves insulin sensitivity, and enhances nutrient uptake. The food, in turn, supplies the amino acids and micronutrients that repair and build. Together, they activate molecular pathways, particularly in 1-MPG-1-alpha, that enhance mitochondrial function, promote glucose metabolism, and trigger hypertrophy at the cellular level. This dual approach also promotes neuromuscular health, which is critically important in aging. Many people focus solely on the muscle tissue itself, forgetting that every movement requires a functioning nervous system. Resistance training improves neuromuscular coordination, balance, and proprioception. And when paired with adequate protein, especially from sources rich in B vitamins, magnesium, and antioxidants, it also supports the health of motor neurons and synaptic connections, reducing the risk of falls and maintaining independence. In the longevity research we've conducted, it has become clear that the most robust individuals in their 80s, 90s, and beyond are those who maintained both lean mass and physical activity levels throughout midlife and into old age. These individuals often consume traditional diets rich in legumes, vegetables, and whole grains while remaining physically active through walking, gardening, farming, or manual work. They may not consciously combine resistance training with protein timing in the way a modern clinical trial might suggest, but they benefit from the same principles. What we aim to do now is take those traditional foundations and integrate them with modern science by identifying specific foods like soy-based proteins that support muscle protein synthesis and combining them with structured yet simple resistance training. We can create a precision lifestyle intervention that improves strength, mobility, and metabolic resilience in older adults. Moreover, this strategy aligns with a broader pro-longevity framework. Unlike high-protein meat-heavy diets that may increase IGF-1 and promote inflammation, plant-based leucine sources are metabolically safer, and resistance training improves insulin sensitivity, reduces visceral fat, and supports cardiovascular health. This makes the combination not just effective for muscle, but also protective across multiple systems. Importantly, these interventions are accessible. One does not need a gym membership or expensive supplements. A resistance band, a few square meters of space, and simple whole how the longevity diet supports muscle health, food sources of plant protein are sufficient. With consistency, the changes are measurable. Improved gait speed, stronger grip, better balance, and a renewed sense of vitality. Ultimately, the goal is not to build large muscles, but to preserve functional strength, the kind that allows someone to rise from a chair, carry groceries, climb stairs, or walk to the market. This kind of strength is not cosmetic. It is biological insurance against the loss of independence, the erosion of dignity, and the acceleration of aging. So when we speak of reversing muscle loss in older adults, we must think not only in terms of nutrients or exercises in isolation, but in the integration of both. The food provides the message, the movement delivers the demand. Together, they speak to the muscle in a language it understands, and the result is renewal. When we speak about reversing muscle loss in older adults, it is not enough to focus narrowly on short-term gains in lean mass. The broader question must always remain: does the intervention contribute to a longer, healthier life? In the field of longevity science, this is a foundational principle. Any nutritional strategy must not only solve an immediate problem like sarcopenia, but also integrate into a larger framework that promotes systemic health, slows biological aging, and reduces the risk of chronic diseases such as cancer, cardiovascular disease, and type 2 diabetes. This is where the longevity diet comes in, developed over 2 decades of research at the Longevity Institute and grounded in the study of centenarian populations across the globe. This diet represents more than a collection of healthy foods. It is a scientific synthesis of the most robust cross-cultural dietary patterns associated with extended health span and lower mortality risk. And one of his key features is the emphasis on foods that can be consumed daily and safely for decades without creating imbalances, inflammation, or metabolic stress. The high-leucine plant-based food we've been discussing, specifically fermented soy products like tempeh, edamame, or tofu, fits seamlessly into this pattern. Not only does it provide the amino acid support needed to combat muscle loss, but it also aligns with the core pillars of the longevity diet: low in added sugars, low in saturated fats, rich in fiber, and abundant in micronutrients. Let us consider these components in more detail. First, the low sugar content. One of the most damaging aspects of the modern Western diet is the chronic real science behind long-term use overconsumption of refined sugars and simple carbohydrates, which accelerate aging by promoting insulin resistance, oxidative stress, and glycation of proteins. These processes impair mitochondrial function and drive inflammation, both of which contribute to muscle breakdown and metabolic dysfunction. By contrast, minimally processed soy products are very low in sugar, and when consumed with vegetables, legumes, and whole grains, help maintain stable blood glucose levels even in older adults with impaired glucose tolerance. Second, low saturated fat diets. High in saturated fats, particularly from red and processed meats, butter, and full-fat dairy, are consistently associated with increased cardiovascular risk and higher levels of systemic inflammation. This inflammation doesn't only damage arteries, it accelerates muscle loss and interferes with protein synthesis pathways. Plant-based protein sources such as tempeh or tofu are naturally low in saturated fat and contain beneficial fats including omega-6 and small amounts of omega-3 ces, which support both heart and brain health. This makes them suitable for long-term daily use without overloading the liver or promoting lipid imbalances. Third, high in fiber. While protein is essential for muscle, fiber is essential for the entire aging system. It feeds the gut microbiome, reduces inflammation, supports bowel regularity, and improves nutrient absorption. Importantly, gut health is tightly linked to muscle health through the gut-muscle axis, a relatively new field of study revealing that microbial metabolites can directly affect muscle strength, recovery, and mitochondrial function. The fiber content in soy and legumes also helps to lower LDL cholesterol, regulate appetite, and reduce visceral fat, all of which contribute to greater vitality in old age. Fourth, abundance of micronutrients and phytochemicals. Fermented soy in particular is rich in vitamins, especially B vitamins, minerals such as magnesium and potassium, and compounds FAQ from our community like isoflavones. These bioactive molecules have been shown to have antioxidant, anti-inflammatory, and even hormone-balancing effects, especially important for post-menopausal women at higher risk of both sarcopenia and osteoporosis. Isoflavones such as genistein may also support bone density and cardiovascular function, providing a broader anti-aging effect across multiple systems. But perhaps most importantly, this food is safe for long-term use, a point that cannot be overstated. In our research, we often find that certain diets may show short-term promise in boosting performance or weight loss, but fail when applied over the long-term. High-protein, high-fat animal-based diets, for instance, may increase lean mass in the short run, but often lead to elevated EGF-1, chronic inflammation, and greater risk for age-related diseases when sustained over years or decades. The longevity diet avoids this trap by recommending protein sources that stimulate regeneration without triggering overgrowth. This is why soy and legumes are central. They offer the essential amino acids required for tissue maintenance, but do so in a way that supports cellular balance, not excessive stimulation. The diet also emphasizes periods of low protein intake, such as through fasting mimicking diets, FMDs, which have been shown to trigger autophagy and stem cell-based regeneration. After these periods of catabolic reset, reintroducing a high leucine plant-based protein helps to rebuild lost muscle in a more youthful and functional way. This cyclical strategy, periodic fasting, followed by strategic refeeding, may represent one of the most powerful anti-aging tools available today, and the food in question supports this model perfectly. Final thoughts and action plan. Finally, we must consider the cultural and practical sustainability of any dietary intervention. Temporary, tofu, adamine, and legumes are affordable, widely available, and can be incorporated into a wide variety of dishes. They do not require exotic supplements or costly preparations. This accessibility makes it possible to adopt a musloop supporting longevity promoting diet in everyday life, not just in clinical or experimental settings. In summary, the food we focused on is not only effective for combating muscle loss in older adults, it also meets the highest standards for long-term health. It fits within a pattern of eating that promotes optimal nutrient density, cellular health, low inflammation, and disease prevention. It supports muscle tissue without compromising metabolic or cardiovascular integrity. And perhaps most importantly, it is a food you can eat every day for years while still aligning with the principles of a diet designed not just to extend life, but to improve its quality.